So let's look at one final problem where we're dealing with a word problem and a finite geometric series. So this one's a little bit more challenging, but it begins by Alex earning a $35,000 salary in his first year of his career. So that's our starting amount. That's A in the formula that I just recopied. And each year he gets a 3% raise. So every year, the amount of money he will make will increase by 3%. So this is the tricky part here. How do we represent a 3% raise as our common ratio? Because you might be tempted to say that R is 3%, but this wouldn't work because then going from year to year, his salary would become significantly smaller since 3% of 35,000 is significantly less than 35,000. So that wouldn't be the right approach. The way to think about it is that each year he's going to get his original salary. So he'll get at least 100%, and then he's going to have 3% added on top of that. So if we convert these to decimals, 100%, that's just 100 divided by 100, which is 1. This is 3 divided by 100, which is 0.03. So if we add these together, we get 1.03. So it looks like from year to year that Alex will multiply his salary by 35,000. And we need to come up with an expression that gives the total amount Alex has earned in his first N years of his career. So it looks like the number of terms in our series in this case is just going to be n. So if we want to write out what the series looks like, this sum here, Alex starts with 35,000, and the next year he'll take that original starting amount and get a 3% raise. So he's going to multiply that by 1.03, and for the third year, he'll have the amount that he made the year before, that 35,000 multiplied by 1.03. But again, he's going to get a 3% raise. So we're going to multiply this again by 1.03, or now it's squared. Of course, we would keep going. The next one would be 35,000 multiplied by 1.03 to the third power, and so on, all the way up to the nth year. And that term will look like 35,000 multiplied by 1.03 raised to the n minus 1 power. So you might wonder why the exponent is not n here, but the way to think about that is to consider what your term values are for each of these. So this is year 1, 2, 3, 4, and so on. So this is the nth year. And notice that the exponent is always 1 less than whatever the term value is. So that's why this would be n minus 1 rather than n. And of course, the way to actually add this up, since we need to keep it very general, is to use the formula. We don't know exactly what year his career will end, so we can't actually plug in a specific n value, but we can use this formula. So we can say that S is equal to A, that's the starting amount, that's 35,000, multiplied by 1 minus the common ratio, which we figured out that's the 1.03, and we're going to raise that to the nth power, and divide everything by 1 minus that common ratio, 1.03. And it looks like we'll need to simplify a little bit. So we can do 1 minus 1.03. That is minus 0.03. And we still have the 35,000 multiplied by 1 minus 1.03. And the 1.03, let me rewrite that, is all raised to the nth power. So looking at our answer choices, there's only one with that negative 0.03 in the denominator, and it looks like our numerator is exactly what we came up with. So choice letter A would be the correct answer here. That tells us how much Alex earned in his first N years of his career.